Alright guys, as we continue to rock through 5.3, we have so far covered the rules of integration. We have gone through a couple of examples of how to use the rules of integration in evaluating some integrals without just giving some general terms, f of x and g of x, to the functions themselves and not an actual function with variables and things kind of like that. And so we have two goals of this video. The first goal is to look at how to find bounds of an integral. And the second thing we're going to look into is one of the parts of our goals for 5.3, which is to look into and use the average mean value for an integral. So let's dive right on in and find the bounds for an integral. It says, show that the value of, in this case, the integral from 0 to 1 of the square root of 1 plus cosine of x is less than 3/2. So we want to show that the integral from 0 to 1 is less than 3/2. Alright, so let's take into context first and foremost. Integrals, less than, so on and so forth. This is using our focus of the max and min inequalities, in which this was stated that the min of f times b minus a is less than or equal to the integral of a to b of f of x dx, which is less than the max of f times b minus a. And so basically what we're trying to show is that the max in this case is less than 3/2. So we want to show that the max is less than 3/2 here. So let's kind of take into account here. I'm going to rewrite this integral from 0 to 1, square root of 1 plus cosine of x dx. All right. So let's think here for a sec. The absolute maximum for this integral. So it's only from 0 to 1. So let's think about what happens here. What is going to give us the absolute max number? Okay, well, let's say, for instance, I throw in 0. Well, 1 plus, in this case, the function, and we're talking the function here, so I'm not talking the integral, I'm talking the function of square root of 1 plus x. So let's say I take the square root of the function of the square root of 1 plus x. And let's say a cosine of x, 1 plus cosine of x, keep saying this wrong. So 1 plus cosine of x, and let's say I use 1 as my first value here, all right? So 1 plus cosine of 1, square rooting, or our other option is 1 plus cosine of 0. All right. Well, which one's going to be our maximum? Well, right on off the bat, cosine of 0 equals 1. All right. Cosine of 0 is 1. Cosine of 1 is not 1. So the cosine of 1 or 0 is 1, and so that means that 1 plus 1 is going to be the square root of 2. Well, the square root of 2 is going to be bigger than the square root of 1 plus cosine of 1. Well, roughly, we'll call it the square root of 2. 1.41, give or take a few, all right? So 1.41 or so is the square root of 2. And so if the square root of 2 is my maximum, by our inequalities, our max and min inequality rule, we know that from 0 to 1 of square root of 1 plus cosine of x dx, it will definitely be less than or equal to the square root of 2 times 1 minus 0, right? There is our b minus a. Well, 1 minus 0 is 1, so 1 times the square root of 2 is just the square root of 2. And so since we have square root of 2 is 1 plus cosine of x dx, square root of 2 is 1.41, excuse me. All right? Well, 1.41 is less than 3/2. 3/2 is 1.5. So boom, we have already gone ahead and shown that it is going to be less than 3/2 by bound. Okay? All right, so the second part of this video was to look into what we call the average mean value. Average, if it all right for me, there we go. Average mean value for an integral. All right, so let's talk here for a sec. Let's say if f is integrable, I'm writing this wrong, I spell this wrong all the time, integrable, integrable. All right, so we're saying f is integrable on a interval from a to b. The average mean value for a to b will be found, we usually write it AV of f, AV of f, average mean or average value of f, is equal to the fraction 1 over b minus a times the integral from a to b of f of x. This is going to find us the average mean value or the average value from the interval from a to b. All right? And the best way to look at this is to take a look at an example first and foremost. So let's take a look here for a sec. Let's say the question's wanting us to find the average value of a function over a particular interval itself. All right, I apologize for that, guys. OneNote's been giving me a little bit of an issue. So let's take a look here. So let's say find the average value of f of x equal to 4 minus x squared on the interval from 0 to 3. And then there's a second part of the question too. It says, does f actually take on this value at some point on the interval? So we're trying to find the average value from 0 to 3, but it's asking, okay, the average value is one thing, but does the average value actually happen? Is it actually going to be a value for x from 0 to 3? So let's take a look. So using what we know about our definition, all right, so we have that AV of f is equal to 1 over b minus a from the integral from a to b of f of x dx. So our function that we are dealing with here, so AV of f, well, 1 over b minus a is going to be 1 over 3 minus 0 of the integral from 0 on to 3 of 4 minus x squared dx. Okay? And so now we're kind of just going to be a quick little evaluation of this particular integral. So it's really 1 over 3 minus 0 of the integral from 0 to 3 of 4 minus x squared here. Okay? Well, doing our integral, we can see that the integral from 0 to 3, this will have a value of 3 since we don't have anything here for this lower limit, really. So we're going to have equals 1 over 3 minus 0. And this will be multiplied by 3. And then, well, 1 over 3 minus 0, that's just going to be 1/3, or a value of 1. And so, to answer the question, the value or the average value of the integral from 0 to 3 is 1. And so now, the question says, can the f function actually take this value on at some point from 0 to 3. So let's think about this for a second. The function assumes the value when 4 minus x squared equals 1. So when does this happen? Well, this happens, the average value of f will happen if 4x squared equals 1 at some point. Well, it is going to at some point because I can actually solve for x here. So negative x squared minus negative 3 equals negative 3. X squared equals 3. Rooting x will equal plus or minus root 3. All right. So you got to kind of think here for a sec. Do both of them work? Remember, the interval is only from 0 to 3. So since the positive side of things, x equals root 3, falls in the interval from 0 to 3, we can use the integral, or the value of x is root 3, okay? Root 3 here, okay? All right, guys. So that is going to wrap up this lesson here, and on to the next one.